Hey everybody, welcome to Bill Sky, the C++ guy, and we're going to look at class members today, object-oriented programming in C++. Now, class members simply mean attributes or variables, methods or functions in an object class. And I think the best way to do this is to jump into it with coding, so let's get going. All right, so I've got a real simple little project set up here. I really haven't done anything, and I'm going to go ahead and create a class called, I don't know, let's create a class called building. So I'm going to right click on SRC in my project, and I'm going to say new class. And from within there, I'm going to type building, and I'm going to end it with HPP because PP stands for C++. So if it was a C compatible header file, I would just say .h. So I'm going to leave everything else alone and just click finished. Alright, so if you looked at my introduction to object-oriented programming under advanced C++, this should be nothing new to you. But what we're looking at right now is the definition of the class. Now again, if you don't know what a class is, if you don't know what an object is, go ahead and take a look at my previous video on Introduction to Object-Oriented Programming with C++, and I go through all that. But let's create a couple of variables. Now, one thing to remember when you're creating variables is you have to decide, because there has to be some design involved here, you have to decide whether the variable will be public or private. And public means that the entire world will be able to see them. And I'll go ahead and create both here. Private means that only the class can see them. So let's, under public, let's just say integer number of floors. And then what I'm going to do now is I'm going to create a statement or syntax called private. And I'm going to say integer, I don't know, what do we want to do here? Total square footage. And let's see, let's take a look at what those different things do, public and private. Let's take a look at those. So I went ahead and saved that. Now I'm going to build it, and Eclipse built everything for us. So I'm going to go back to the CPP, and to actually be able to use my building class, I have to say #include building.hpp. And we'll be talking about the difference between this type of an include and that type of an include in a different video. But for right now, it's just double quote building.hpp. I'm going to go ahead and save and build that, make sure it builds okay. Okay, so what does this actually do? Let's go ahead and create a variable. So I'll say building, I don't know, building 101. So that is a static building. I did a video previous to this one on object pointers, so take a look at that if you want to mess around with a pointer. But I'm going to create a building called building 101, and I'm going to save it. And I'm going to now say building 101 dot. And Eclipse will go out to the class, and again, the class has to be saved on disk. It'll go out to the class and find all of the members for that class. Now notice, all we see here is number of floors, the building constructor, which is this one right here, and then the building destructor, which is that one. Well, what about the total square footage? Where is that? Well, the reason that is not available to us is because that's private. So it's only available to the class. Now, what do they call that? They call that data hiding. That is something that is hidden from the outside world, because it has to be managed and protected by the class to make sure that valid data has been put into it. So let me explain to you what that means. So I'm going to say building dot number of floors equals -900. Now that makes absolutely no sense that I put -900 into a class variable or into an object variable or into an attribute of an object, in this case number of floors. It doesn't make any sense. So a class can be set up in such a way to make that variable hidden, and then you have to ask the class to set its value to some value. And again, that's called data hiding. So how do we do this? How do we make total square footage be visible to the outside world, or how do we make the class manage number of floors so we don't put something strange in there like a negative 900 floors, or maybe a positive 10 million floors. I mean, it's not even possible. So how do you do that? Well, what you do is you make everything private, and then you set up a thing called getters and setters, and those are public methods that allow you to send data to those methods or those functions and let the class decide whether or not it's a valid number. So let's try that. So I'm going to save this class now. And now if I go back to my main, I'm going to see, does number of floors exist anymore? Number of floors doesn't exist because we made it private. So let's go ahead and generate our getters and setters. Now this is one thing I absolutely love about Eclipse, is that you can select your getters and setters. And it's been a little while since I've done this, so let's see if we can do this. Yep, so I go under Source on Eclipse, and it says Generate Getters and Setters. So I'm going to click on that, and it shows all of the variables that, or all of the attributes that are private inside of the class building. I'm going to click on Select All. And I'm then going to click on Definition is separate from declaration. And what that means is that it's going to move the actual implementation of the getters and setters of the functions into the CPP file, which is where they belong. And it's just going to put the prototypes in the HPP file. That's really what you want to do. And you can go ahead and preview it. What is the code going to look like? That's okay. Let's just go ahead and click OK, and let's see what happens. So by doing this, what happened is Eclipse generated these 4 functions, 2 functions per attribute, per private attribute. One is the get number of floors. That's going to return an integer. Why? Because number of floors is an integer. And it's got a set number of floors, which takes an argument number of floors. So what you're going to do is you're going to call that function set number of floors. You're going to specify a value and let the function inside the class decide whether or not it's a valid value. And it returns void. Now, I like to return Boolean, and you're going to see why. So all of my setters, I like to return Boolean. You can change these. Eclipse did that for you as kind of like a template for what to do. So I changed all those to Boolean. You're going to see why. Now, when you change something in the HPP file, you also have to change it in the CPP file. And the CPP file is where Eclipse added the code that you're going to actually implement here. So on all of my setters, I'm going to change those to bool. Now, one of the things that Eclipse did, which I've always thought was absolutely ridiculous, and it wasn't just Eclipse, it's any object-oriented programmer that does this. I just think it's ridiculous. Go ahead, send me messages, I don't care. Is that if you just blindly put the value that the setter has been given into the variable, the attribute inside the class or the object, you have completely missed the whole idea of data hiding and data protection. Is that you don't want to just blindly have the number of floors be negative 999. You want to actually check it first to make sure that the programmer put in a valid value. So let's go ahead and do that for set number of floors. I'm going to say if number of floors is less than 0, I'm going to return false. Notice I'm not setting any value inside of the function, inside of the method. I'm just returning false. I'm saying this is not a good thing. It's not. It does not fall within my range of valid values. It's a negative number. You might also want to say this: if it's less than 0 or number of floors is greater than, I don't know, what's the largest? Let's say 200 floors. That's pretty high, but let's. So if it's less than 0 or if it's greater than 200, the building class is going to say, hey, this doesn't make any sense. I'm not going to set this data for you. Okay, I'm just going to return false and not change anything. And because I like to finish up all of my if statements, I'm going to go ahead and do that. So what you can do then in your main is that when you create a building and you say that I want to set the number of floors, you can then check to see whether or not that is it's valid. It was set correctly. So let's go ahead and build this. All right. So I actually have some problems here. Let's take a look. Okay. I didn't actually return anything here. So let's do the same thing for set total square footage. So I'm going to do the same thing. I'm just going to copy and paste it. And total square footage, you know, that's kind of a hard number to say here's a maximum size. So I don't know, you could come up with some really strange size, but we're just going to go ahead and say if it's negative, we're not going to do it. And then we're going to say return. Oh, so then we're going to say else and then return to. I'm still getting an error, so let's say where I'm getting an error. I'm getting an error in my main, so that's fine. Okay. Oh, I probably shouldn't have done that. And again, I always like to have this goodbye, just because I want to be able to say that the program ended, and I can tell that. Okay, so building 101. Now let's take a look at building 101 dot. We have a number of different things here. We don't see any attributes. We don't see any variables, but we see functions. So I'm going to say set number of floors. And I'm going to put in a negative 900. Now here's the really neat thing about returning Boolean is I can check it. I can say if that is true, count of floors has been set correctly. Else, and we're going to do another cout, count, whatever you call it, GIF, GIF, doesn't matter. Number of floors has not been set. So you're protecting the data by having that logic inside of that class. Okay, it built just fine. Let's go ahead and run it. Okay, number of floors has not been set because I put an invalid value in there. Let's test something else. 3,000 floors. Let's say a positive 3,000. It has not been set. Okay, so let's put it has a total of 50 floors. Still a pretty big building. It has been set correctly. So that's where... Now, if you just blindly set the number of floors in the class, you're not protecting the data. It's hidden, but you're not protecting it by just blindly putting it in there. And by specifying a Boolean return, there's nothing wrong with that. You can actually check to see whether or not it worked. Now, why would you want to do this? Well, what if you have, I mean, if you have hard-coded 50 floors in there, why do you care if the class checks it? Well, I understand, that's fine. But what if you do something like this? Please enter the number of floors in our building. And we do a kin to user integer. So I'm going to assume the user typed a valid number in there, okay? And instead of putting in a hard-coded 50, we say user integer. Now, I could really clutter up my main very easily by doing all kinds of ifs to make sure the user typed in a valid number. Or I could let the class do it. Wow. Boom, right? Let the class worry about it. Let the class worry about its own data. Why should the main worry about it? Why should the main say, I'm going to make the user type in a value? I have to know everything about the class, and I'm going to force it to tell the user that there's a problem. So what you can do is you can actually put this in a while loop, while true, and I'll probably get some mean letters about you should never use while true, but that's okay. I'm just teaching today. Okay? And when it's been set correctly, I'll break out of the while loop. So very, very clean code here, right? We're just checking to see whether or not it's a valid value. I don't know anything about building. Let's say I've gotten this object file about building. I've gotten this class as an object file from some other programmer, and I don't have all the documentation, right? I don't like reading documentation, all right? But using code like this, if the class is built in this fashion, you don't have to have the documentation. The class will tell you what is valid. So let's go ahead and build this and let's run it. All right, I'm going to put negative 900. Number of floors has not been set. You might want to have a little bit better of a display. I'm going to put in 50,000. Okay, I'm going to put in 10. Boom, number of floors has been set correctly. So you're letting the class tell your main what is right and what is not right. And you can do the same thing with all of your functions, all of your methods inside of your class. We did it with set total square footage. We decided a negative isn't good enough. You might also want to say, what is the smallest building you can have? I don't know, somebody's mini house that has 600 square feet. You can do all kinds of stuff inside of your class to help protect your data, to make absolutely sure your data is protected. Now, something else that Eclipse does that I don't necessarily like a whole lot is that when it generates your setters, the variable name that is sent to the setter function is the same name as the attribute. So Eclipse then uses this statement. It means that the number of floors of this object should be set to the number of floors variable that was sent to the function. So I don't do a lot of that. I use a lot of this. I use that a lot. But normally I won't make my variable number of floors. I'll just make it some integer. I'll make it something like that. Like I'll say something like some int. And just because I just like a generic name, some people may not like to do that. They may actually like to do it that way. I'm thinking Eclipse does it this way because the majority of developers like to do it that way, and that's fine. But if you do that, you must put in this, the object that's currently being affected number of floors variable. So that's the setters. So setters are great, okay? What are getters all about? Well, I'm going to come down here. I'm going to say count building 101 dot, and I'm going to say get number of floors. So number of floors was not available as a variable because we placed it in private, but the getters and setters are there. So let's go ahead and run this. Let's make sure everything still works. Minus 900, 50,000, 40,000, or whatever it is, and I'm going to put in 20. So the getter grabbed the data from inside of the class or inside of the object and returned it, and that's what this getter does. Now, this video is about class members. Well, a class member can be a function like this. Let's say that you want to create a new attribute called float. Well, let's make it a double. Average floor square feet. Okay. Now I'm going to save that, and I'm going to say source generate getters and setters, and I'm just going to say average floor square feet. Now notice Eclipse didn't show you the other two class members, the attributes, because they've already been set up. So I'm just going to go, I added a new one, so I'm going to let Eclipse do all the work for me. So there's my getters and setters. Of course, I always like to have a bool on the setter. Now normally buildings, each floor has the same, it has the same basic dimensions, so it has the same square feet. I'm going to go into my CPP file. And okay, let's change the setter. So I'm going to say if average floor square feet, that is the value that was sent to the setter, is less than 0, or average floor square feet is greater than, I don't know, 20,000. That's a big floor. I'm going to return false. else. I'm going to go ahead and set it. All right, let's save and build that. All right, great. It says we have a problem here. Oh, I never returned. So I'm going to say return. Sure. So we have to make sure we return true if it was set. All right. So let's go ahead and do that. So I'm going to go ahead and I'm going to say building 101 dot set average. Oh, that's get. You don't want to do that. You want to say set. And I'm going to say, I don't know, 1,000 square feet. Now, getters and setters are one type of method class member, but you can also create your own. I'm going to go into the HPP file, and I'm going to say double get total square feet. And I'm going to create my own custom public method, my own custom public function. So I create that in the HPP file. Then I go into the CPP file, and I just copy and pasted the prototype for that function, and I have to put the class name in front of it with 2 colons. That means that in the CPP file, I am saying that that function, that method, is part of the building, in this case, the building class. Okay, so that's my own custom one. I didn't have Eclipse do it for me. And what I'm going to do is I'm going to return this dot. Notice the variables are now available to me because I'm inside of the class definition. Average floor square feet times this dot number of floors. And I always like putting my equations in parentheses whether or not it needs it. But I do that all the time. Let's build it. And what did I do? Oh, I forgot a semicolon at the end. So there, I just created my own getter. And it's real. And the reason that I created my own function is because I don't want the total square feet to be set in stone. Excuse the pun, if that is a pun. But I want it to be calculated. I don't want the data to be sterile. If I decide to add another floor to the building, I now have to manually change the total square feet. This way, if I decide to add another floor to the building, which is possible, it's automatically calculated. So that's where stale data can be a problem. And I'm still protecting it. I'm still... It's completely protected because it's calculated. All right. So I've set it. I've set the total number of floors. Now let's say cout building 101 dot get total square feet. Now let's remember that the average floor feet is 1,000 during our test. Now we could all do another while loop, but okay. So enter the number of floors. I'm going to say 10. 10 floors. We know that the average floor feet is 1,000. So we have a total square feet of 10,000. You might want to say make it a little bit nicer. Let's try this test again. And there you go. So you've created your own function. It can be called anything. I could have called that function stan. It doesn't matter. But you do want the method. You do want the method name to be actually meaningful so the programmer that's going to use your class knows what it's going to do. Also remember, if you create a function stan in the HPP, you then have to come into the CPP file and create the actual implementation of the function, and that implementation needs to include the class name : : Very important. Watch what happens if I don't put that in there. if I leave that build. And I've seen students do this all the times. They don't know what the problem is. Well, let's go ahead and just return something. Let's return 100. Let's just do that to see if we have an issue. So it compiles okay, but watch what happens if I try to run stan. There's stan. I actually get a linker error. The linker says, I don't know what stan is. The compiler said, okay, no problem. And why did the compiler work? Because we put it in the HPP file. However, we never implemented it. Well, you say, well, yeah, we did. There's stan right there. But we didn't implement it for the building class. And that's why you have to put building : in front. And now when we build and link it, no problem. So what have we done in this video? We have created a whole bunch of getters and setters, each one for our private variables. In this case, total square footage, number of floors, and average floor square feet. We created our own custom functions, one that does nothing really, just called stan, and another one that keeps us from having to have stale data in the class called get total square feet. Now, can you put functions inside of private? You betcha. I could say double stan2. And let's go ahead and do that. And it's going to be easy because I'm just going to go ahead and copy and paste. And call this stan2. And that's going to return 200. I know it's a silly function, but just bear with me. Compiled okay. Let's go to our main, and I'm going to say couch building 101 dot. And is stan2 there? Nope, because stan2 is private. The function stan2 is private. Why have a private function? Well, let's say that your class is going to do some proprietary copyrighted algorithm, something that you've actually gotten a patent for, and you don't want anybody to see your algorithm. You don't want to actually make that available to the general public. It's not open source, right? You want to make some money on it. So what you do is you put that in a function inside of the class called stan2, and nobody can get to it. However, your class can get to it. And let me demonstrate that. So I'm going to go back into my CPP file. Stan is going to call stan2. And there is stan2. Now that doesn't do anything, but you can see how the class can see it, because the class can see its own private members. The public in our main cannot, because it's not public. So I can create functions as private members, as you can see here. I can create variables as private members. You can even create your own variable that you don't want anybody from the outside to see. It's just something that you're going to use. You can make it private, and then you won't even need to create any getters and setters. Just go ahead and make it private and use it within your functions. So like within stan, I can say this dot temp double. I don't know what you're going to do with temp double, but I'm showing you that you're able to create your own variables that only you can see and you never want to expose to the outside. Wow, that's an awful lot. But it gives you a starting point as to how to set up public and private variables inside of your class, and how you can use those within your class, and how you can expose them to the outside world as public, and also how you can keep them protected so bad data doesn't go into your class or into your object by making them private and creating the setters with Boolean return types, allowing you to say, hey, you did a good job. I went ahead and set that data for you because you sent me the right value. Hope to see you at our next video.